Hi everyone, this is practice formative of chapter 4, question number 15. So in this question, we need to find the number of ways to arrange 7 family members at the round table. So at the round table, our formula will be either NPN divided by N or NPR divided by R, okay? Now over here, we have 5 vacant chairs and both parents must sit next to each other. So these 7 family members, we will have 2 parents and 5 children. So the parents must be in. That means we only have 2 parents plus 3 children who get to sit around the table. So how do we do this? First of all, parents must sit together. Therefore, it's considered one item. And then the 3 children. Now, how do I choose these 3 children? We can combine with the combination. So 5 children, we choose 3 so that we can put these 3 children to permute together with the 2 parents. So since 2 parents must come together, they are considered one item. So one item plus the 3 children altogether, we have 4 items to permute. Therefore, in the circle, that will be 4 minus 1 factorial, okay? And parents, they will permute among themselves. So we have to multiply with 2 factorial. So with this, okay, let's use the calculator, 5C3, we choose 3 children out of the 5 children to permute with the parents. So because they sit in a circle, we have to take 4 minus 1 factorial, that is 3 factorial. And parents will sit together, their position will change, so they will permute among themselves, so times 2 factorial. So the answer is 120 ways. Okay, now let's say some of you may not understand what is this. We shall use the sketching to help us to understand the situation. We have 5 empty chairs. So 1, 2, 3, 4, and 5, whereby parents must sit together. So these 2 chairs, we bind it together, and that's specially for parents. So let the parents sit in. So once the parents take up the space, so the 5 children, right, they will have 3 chairs for them to sit. So for this chair, we will have 5 choices of the children, followed by 4 choices of the children, followed by 3 choices of the children. Okay. Now, parent to sit in, there is only one way. The first person who sits at the round table is always one way, because whichever chair that the first person sits, the front, the left, and the right chairs are all empty. So it is the same, whichever chairs that he chooses to sit. So the first person to go in is always one choice. And then because these parents, among themselves, they can change their position. So internally, we will have 2 factorial and 1 factorial. So all in all, the number of arrangement will be 5 times 4 times 3 times 2 and times 1. Okay, this is based on the illustration by fill in the slot. All right, so 4 times 3 is 12, 12 times 5 and 2, which is 10, that is 120. Okay, and part B, we have 7 vacant chairs. Okay, and we have 7 family members, so all will sit in, but both parents must sit next to each other. So again, 2 parents, consider one item, and then plus 5 of the children. Okay, 5 children. Therefore, how many people are there for us to arrange them? We consider 6, 5 plus this one item, one group. So we have 6 items to arrange. So when they sit in a circle, 6 minus 1 factorial. Okay, or if we were to use this one, that will be 6p6 over 6. Okay, so 6 minus 1 factorial, that is the 5 children and 2 parents, and the parents, because They sit side by side, so among themselves, they will permute each other 2 factorial. Okay, so let's use the calculator. 5 factorial times 2 factorial. 5 factorial times 2 factorial. So we have 240 ways. 240 ways. Now let's say you can't really see the logic by just writing this symbol. Okay, let's illustrate it. We have 1, 2, 3, 4, 5, 6, 7, whereby parents must sit together. So let's parents sit in. So the remaining of the 5 children will take the space. So now we have 5 choices, 4, 3, 2, 1, and the parents will permute among themselves, 2, 1. So therefore, the number of ways, the number arrangement will be 5, 4, 3, 2, 1 is 5 factorial, and then the parents arrange among themselves, it is 2 factorial. Isn't it the same as this? We get the same answer, 240 ways. Okay, to arrange the seats around the table. All right, now part C. We have 10 vacant chairs and both parents must sit next to each other. So this one, we have 10 empty seats. Okay, n equals to 10 and 2 parents must sit together. So everyone will have their seat. So plus 5 children. So over here, our R is, take it as 6 items. Okay, 6 items. That means the n is also 9. All right, so we have 6 items here. Okay, so if I were to use the permutation notation, that will be 6. No, we have 9. 9 P6, and then we got to divide by 9. All right, and then followed by the parents permute among themselves, 2 factorial. Okay, let's check the answer. So we have 9P6. Okay, 9P6. And then divided by 9. Because we have 9 chairs along. And then times 2 factorial. So 13,440. 13,440. Now again, if we were to use the fill in the slot method, okay. Right, let's use that. We have 10 empty seats. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's choose this, the parent must sit in. And then we have 1, 2, 3, 4, 5, 6, 7, 8. 8 chairs. And these 8 chairs is for 5 children. So this 8, we choose any of the seat to put in our 5 children. All right. And since parents is the first one to choose the place, therefore, there is only one way to choose the place for the parent. So we fix the position of the parent. So the remaining of the child will go in. So it will be 8P5. And then the parents will permute among themselves. So 2 factorial. Okay, let's use the calculator. 8P5. We have 8 empty seats. So just choose the 5 children, just choose any of the 5. Okay, out of the 8, just choose any of the 5. And then followed by the parents, permute among themselves. So the answer is 13,440. Same, 13,440. Okay, so that's it for question number 15.